Dear ladies and gentlemen, welcome to the new features in KISSsoft presentation for release 2018. My name is Ilja Tsikur, and we have quite a lot of new topics in the new release. I will cover the cylindrical gear part, so everything that's new for cylindrical gears. So basically up to 0.4, and then my colleague Mr. Langhart will continue with other topics like bevel gears, shaft and bearing calculations, but also some new things for conical compression springs. So let's go through what highlights do we have in the new release. First of all, one of the main highlights is the possibility to calculate asymmetric tooth forms. Let's say also quite a new topic in the industry. And in addition to that, we have an additional module to calculate 3D root stresses with the help of our internal finite element method calculation tool, Salome. Maybe you've already seen it or heard it before. In the contact analysis, we have the option to calculate, in addition to the transmission error, now also the excitation force for the evaluation of gear noise. And also some new topics for manufacturing. Since we are now part of Gleason family, we also try to add some manufacturing specific modules into the software. And this year the highlight is the calculation of manufacturing twist, which occurs for helical gears that have also a crowning as a profile, or sorry, as flank line modification. Then we have the draft standard for the calculation of scuffing for bevel gears. We will also show you how easier becomes the shaft modeling inside our shaft calculation module. And we will also show you then at the end the new conical compression spring calculation. Maybe I would like to add before I start one more thing. This year we had to split the release presentation into two parts. We were going to show you now the KISSsoft part, so what's new in KISSsoft. And on the 21st of June, we have a special web demo, also in the same format as now, but for KISS's related features, so for system calculation. All right, so I will start with cylindrical gears. I have opened now example 1 if you want to follow. So the first thing you're going to see is that we have divided now the reference profile input data into, let's say, into one sheet. It's now in front of your eyes for both gears. Before, you always had to switch gear 1, gear 2, and that way you have a better overview of the input parameters for both gears at the same time. If you go to module-specific settings, you will find that there is a possibility now to activate these, let's say, two new features that we have. First of all, the gear data exchange format. This will allow you, I will show you later on, this will allow you to easily transfer gear data from KISSsoft to, let's say, a manufacturing machine or a measurement machine. But what I want to focus on now is the calculation of asymmetric teeth or asymmetric gears. And now you see, once I've activated this setting, the input fields inside the basic data tab have changed. Now we can enter a different pressure angle for the left and for the right flank, which basically will then generate our asymmetric gearing. But before I do that, I just want to show you the results for the flank safeties. If we have basically asymmetric toothing or asymmetric gearing, now you can see that we have here a flank safety of 1.3 for the pinion and about 1.4 for the counter gear. If I enter this asymmetric toothing, I will hope to achieve better results for the flank safety. So let's do this. I'll enter a pressure angle for the left flank of 15 degrees, and for the right flank, I'll go up to 30 degrees. In addition, if I now go to the tab reference profile, I can size the maximum root radius coefficients, and you can actually see now that we are entering the reference profile for left and right flank separately, and that for gear 1 and gear 2 separately. So I will size now the root radius coefficients, and I can perform now a calculation. What we had to do is we had to split the warnings and error messages now for the left and the right flank so that you understand for which flank actually these messages are coming. So now we have messages for the right flank, and you can see we have here some warnings regarding micropitting calculation. Now come the messages for the left flank, and here we have a specific sliding that is much too high, which may be an indication that wear may be an issue. Okay, but we have our results now. Let us see what happens with our flank safety, and you can actually see that by adding a higher pressure angle on the right flank, which is our driving flank or working flank, you can see it here, we have increased significantly the flank safety for both gears without reducing very much the root safety. So the root safety is still okay, but our flank safety was increased, and thus we hope to achieve more service life, or basically increase our torque capacity of the gearbox. What's new in addition is that you can go to the graphics and also show the meshing. You can now see we have here a asymmetric toothing. Of course, you can also change the working flank from left to right and then calculate the results again. But you can now also extract the cutter or the tool for example, for hobbing, and you can see the basic rack profile here in red color, which is now also non-symmetric, and I can basically simulate now the movement on the tool for the generation of the gear. Clearly, you can also just activate the tool geometry and say, I want to just have a half tooth form for export, and I could basically read in this tooth form or tool form if you want into another program or into another calculation or in CAD, whatever you want. So that's quite a nice feature. And we also added the generating cut. So here you can actually see how the cutter moves into the gearing and goes out to generate our asymmetric tooth form. Tolerances are also quite a special topic because we don't really have anymore the possibility to enter base tangent length, because for asymmetric toothing, it's difficult because you have different base circles. So now you can either enter the tooth thickness allowances manually, or you can enter, for example, the circumferential backlash. But things like normal backlash are gone simply because of the asymmetric tooth form. But what is available also as a result in the report are the measurement over balls, which allow you to later on check the quality or check the allowances of the manufactured gear. You can also, I have also shown you that you can calculate safety factors analytically for root and flank. But as I said before, we have added also a new feature, which is called tooth root stress calculation with finite element method. If you have special tooth forms, or if you have a very special reference profile where maybe the formulas that are given in the standard are no longer very accurate. And for that, I can go to calculation, FM tooth root stress. And the new feature is we had the 2D FM already in 2017 release, but now we have also the option to calculate 3D FM root stresses, which I will demonstrate now. In order to save some calculation time, I will set the mesh density of the FE model to low, and while it is calculating, I will be giving you also maybe some background. What are the advantages of using this FE-based 3D root stress calculation? Well, first of all, if the reference profile is, let's say, other than standard, and if the asymmetric teething, if you calculate an asymmetric toothing, then you may want to check the root stresses also calculated by FE, for example, to evaluate how far or how close are we to the results from the norm, from the standard. And clearly, if the FE results and the norm results do not coincide at all, then maybe you need to be careful with the analytical safety factors that you get from the standard. So this allows you to get actually a feeling of how accurate or how not accurate you are in a particular situation. Normally, the mesh density that you set, currently I have set it to low. This allows me to still quite quickly perform this FE calculation. If you set it to high, then you may expect some more calculation time. And now you can actually see that my calculation was finished. First of all, let me show you the results. So in the background, KISSsoft is opening our FE, internal FE tool. By the way, this FE tool is delivered along with the software, so you don't have to buy the tool itself extra. But this calculation of 3D root stresses requires contact analysis. It's in a beta stage, so you get it basically this year for free, or in this release 2018, you get this module for free, but you have to have the contact analysis module within your license. And if you don't, you can always ask us for a test version. And now you can actually see the diameter where my 30 degrees tangent is. You know that the root stress calculation is according to the standard calculated at the 30 degrees tangent. Then you also get nominal stresses in the root area, which are here 162 megapascal or Newton per square millimeter. And you can also compare now or evaluate these stresses now to the norm, to the standard. This you see right here, nominal stress in the root rounding. And here you can actually see that that the results do not coincide one-to-one. And of course, because this is also a special tooth form. I will also show you quickly this tool Salome. This is basically our post-processor, and it allows you also to view the results that you got from KISSsoft, and you can also see the mesh. I will open now this calculation file and generate vectors, apply, and now we should be able to see the tooth form. And I can say here I want to show it as surface with edges, and now I can display, for example, the stresses in 3D. So for clearly, many customers also have an FE calculation tool, ANSYS or Abacus, whatever, but this gives you an option to quite quickly, without setting any boundary conditions, without having to mesh it yourself, gives you quite a nice opportunity to evaluate also, in addition to the analytical methods, also with finite element methods, the stresses within the teeth toothing. So I will close this now. So then I slowly continue to the contact analysis tool. I will open my cylindrical gear calculation module and go to calculation, contact analysis. And if I run the calculation now, you can actually see that the calculation speed is quite fast. So you get results. Well, clearly we don't have here shaft files attached, which would normally take then maybe a bit longer, but the calculation is quite fast, efficient. And the additional results you get now within the contact analysis tool is the excitation force. The calculation of excitation force is based on a FVA report, section number 487, if you're interested to read it more in detail. And this allows you to basically evaluate the meshing in terms of noise, this additional feature excitation force, because before we were basically analyzing the transmission error, the contact impact, but also the amplitude spectrum of the transmission error, which shows you basically the shape of the curve. But now, in addition to that, we have the option also to evaluate the forces that are generating within the meshing. This can be used, for example, to compare completely different geometric solutions in terms of noise. This curve can also be saved. If I want, I can just save it as a text file. I will save it as a text file. And now if I open it, you can actually see that you also have now the values from the force excitation, which if you like, you can also import then into your multi-body dynamic simulation tool or wherever you may need these results. So also quite a nice function. Another thing that was changed within the contact analysis module is the stiffness or the spring model of gears with non-equal phase width. If, for example, if I make my pinion now more wide, I'll increase the phase width, I make it wider, you will actually see that the contact analysis runs a bit slower now. This is due to the fact that if we have different phase widths, or let's say a different common phase width of both gearings, then the stiffness model that's behind it was changed. But the advantage is that if you look now at bending stress, for example, now in 3D, oh, sorry, this is the wrong one, stress distribution on tooth gear A. Sorry, I wanted to show you this one. No, not this one, sorry. One up. Yeah, one more up. Yeah, that's the curve I wanted to show you. This curve is for the pinion, and you can actually see that if this is now my phase width, and here you can also see the stresses that we have now here, the certain effect that comes from non-equal phase width. Also, if I change now to gear 2, this is the counter gear, here you have the different effect, which comes from different phase width. So I really recommend also to test these results and to have a look at what changed. But in general, the results for non-equal phase width have become also more reliable, more accurate. Then another thing I would like to show you is the new GDE export. What is GDE? Well, first of all, where do you find it? It's found in the module-specific settings. I already said it before. Here you can activate this option to generate a gear data exchange format. It's according to VDI standard 2610. What is the advantage? If I now go to report, special reports, I can generate, first I need to calculate, of course, sorry. Now I can go to report, special reports, and GDE export. And this is a standard which is basically recognized by different types of machines. So for example, if you would like to transfer the gear data with modifications to a hobbing machine or to a measurement machine, then this data structure is basically then recognized. It allows you to avoid errors when you transfer data from one tool to another. And VDI created this standard to standardize the structure of the data for gears. So that's also quite a nice feature. Last but not least, I've mentioned manufacturing. We have added now the manufacturing twist or the calculation of manufacturing twist for helical gears. So I have to change here to a helical gear. Let's make it maybe 15 degrees helix angle. I'll recalculate now the center distance. That's okay. And now if I go to calculation modifications, let's say if my helical gearing has a crowning, I'll add crowning right here, let's say maybe 15 micrometers. If you do generation grinding, typically, because of the movement of the tool to manufacture the crowning, you get a twist. And it's nice to at least simulate what will be the amount of the twist to predict the behavior of the gearing, but also to compensate this effect of twist if you have experience, of course, how to do it. And I would like to show you now under graphics. First, I have to press calculate. And now I can show you under graphics, geometry 3D, modifications. This would be now the typical crowning. If you don't consider the manufacturing twist, you can see it's quite evenly distributed. And here on this axis, we have the face width. And now I can add a new modification type, which we call twist due to manufacturing for generation grinding. And here as input, you have to enter the amount of crowning. In my case, it's 15, so quite straightforward. And if I press calculate, then the software should calculate the manufacturing twist that results due to generation grinding process. And now you can see it here actually quite well. These are basically the most important new features for cylindrical gear calculations. I hope you liked it. And now I'd like to give the word to my colleague, Mr. Langhart, who will continue with other new topics. Thank you for your attention.
Okay, thank you, Mr. Tsikur, for your nice start in the web demo for the news in the release. I will continue now with the next topics for bevel gears. And with the bevel gears, I will start with the draft of the new scuffing calculation. As you know, KISSsoft is active in the ISO committee, and now in the ISO committee there is now the task to create a new standard, and we have a draft already implemented now in KISSsoft. In KISSsoft you can see that the calculation method for scuffing, now there is added a new calculation method, ISO 10300-20. It's a draft still, but it's already available here. What you typically can see is that if you did the calculation and if you go to the graphics, you can see that for a bevel gear, the created contact temperature during meshing, it starts, but it drops at the pitch cone and it increases again. This is what typically happens for bevel gears, as there is no sliding on the pitch cone itself. So therefore also no contact temperature is created by meshing. It is very much different for hybrid gears, and you know, the hybrid gears, they are more sensitive for scuffing. It's a really big topic to check hybrid gears for scuffing, and we can also see now with this curve that at the pitch cone there is also a risk for, or that there's also contact temperature introduced, and it's a risk for scuffing which needs to be checked by the engineer. So in KISSsoft, this draft is already available now. Okay, I will continue actually then with the next machine elements, and these are the shafts. With the shafts, we have also done quite many new functionalities and improvements, and it's very obvious if you start a shaft calculation from scratch. You can see on first glance, you can see it's an improved layout. We have, for example, we have an grid paper here, so the design engineer can follow very quickly on his dimension what he creates. We have an element box on that side, right hand side. We have an restructured overview in the elements tree, and I will show you now then some points in the handling. For example, a nice handling is if you have a background a design drawing already, and you can put this in the background, you can select it from any DXF file. I have a sample here. I have a sample, and this sample already has a background drawing behind that. So it's typically a sample drawing, and this either intermediate shaft, this is what we would like to model now very quickly. And so to do this, I will just add here from the elements box, I will add cylinders. So I add now 5 cylinders at the moment, and also a new point in the release 2018 is that we have grip points here where we can drag and just give the dimensions to the cylinders by these grip points very easily. So with this functionalities, the background drawing and the cylinders by the grip point, you can see how quickly now the engineer can give the dimension of the shaft. And I would say this is really a nice process, a nice approach how you can design the shafts. Besides the creating of the modeling part, we have here also in the elements tree an overview which lets you select different sub overviews for different topics. You can strictly go on geometries, on forces, on bearings. This is nice to see if you have a more complex shaft, if you have an coaxial shaft, like for example for a truck transmission. So if you go for a truck transmission, we would like maybe to see the bearings only, as we typically have messages for bearings when we do calculations. So we can see now a bearing B8, and it's much easier now to find this bearing B8. This is one of the possibilities in the new overview structure what we have. Another nice possibility is that you can just fold up all elements. So in this shaft we have about maybe 10 individual shafts, and if I quickly want to check anything on one, let's say on the force speed gear body, I can click on show only this shaft. I can maybe check about geometries, and vice versa. I can go back by display all shafts, so I can specifically work on one shaft individually, and this also is much easier now compared to the release 2017. Okay, but not only handling improvements are done in the release 2018, also calculation improvements are added. And one of these I would like to show you now in the bearings. And in the bearings there are, for example, shafts which are supported by journal bearings, typically the turbo or heavy duty shafts. And now we have a new element in KISSsoft. This didn't exist before, and so you can see now this journal bearing. It has, for example, as typically for them, they have a nominal phase width, not an individual point support. Also the attitude angle, the diametral clearance, stiffness, and damping. These are also typical values which are needed for the calculation of journal bearings, and this is also now available in the shaft calculation. But also for the roller bearings, we made improvements in the new release, and this is nice to see at this sample. So if you want to apply the rolling bearing stiffnesses from any other sources. Maybe you have data from your bearing suppliers which you want to apply in KISSsoft. So then it is now possible to give the stiffness value for the axial stiffness as well. This was missing in the previous, but now added in the current KISSsoft release. And with this, beside radial and tilting, now also the axial stiffness can be given, and a complete comparison to other calculations is now possible. As a next sample for a new feature in KISSsoft about bearings, I would like to show you the bearings without inner and outer rings. In the new KISSsoft, it's also possible now to have bearings as conventional with inner and outer rings, but also to have bearings without inner and outer rings. And this is also occasionally applied in the designs, and of course it goes then to the dimensions of the shafts. And now with the new option that the bearing, you can see this in the elements editor, the bearing, they are in the database defined as no rings, so they can be selected, defined and selected as no rings, and then your design on the shaft diameter fits very well to the diameter of the modified bearing. And as a next feature in the shafts, I also would like to show you the handling of the force elements. If you do planetary stages, epicyclics, gears, then so far, and now I use the nice functionality of forces overview. So far in KISSsoft, you always needed to have here, this is the planetary stage, and you needed to define for the internal gear and for the sun gear, you needed to add 3 force elements for 3 meshings. And this is actually okay, but as it is one physical gear only, so the physical gear now can be given as a one gear but with multiple contacts. So, and this makes it easier, as the position, the geometry, the number of teeth and so on, they are of course the same. Still, you can give the details in the plus button, but for the engineer it may look easier to have one force element only. I prepared a file here, so to have one force in the shaft calculation also, and it's just a simpler and easier look and easy to understand. Okay, so these are the new features which we want to show you now in the highlights for shaft and bearing calculation. I will continue now with a next machine element. This is the springs. For the springs, we have added in the release 2018 the type of conical compression spring. You may know already the cylindrical compression springs, and maybe you will not know yet the properties of the conical compression springs, and I want to show you now a typical behavior of the conical compression springs. You can see that now in this, for this spring we need 2 diameters for the begin and the end of the spring. We have a conicity now for 50 and 105. So if we look at the force travel diagram, we can see this behavior, these characteristics of the force travel. And it is now for a design engineer possible to modify that behavior, and we can see now we can individually modify the force, the reaction force on the displacement, and if we change again more, we will get a more linear behavior of the force travel, which finally leads to a nicely customized conical spring. And this is an option which is taken typically for valves or for automotives, for couplings. So if you want to use these types of springs, you can now easily in KISSsoft try with the numbers and adjust the characteristics of your spring as you need it. Okay. Then of course, beside of this, new features in the springs, also in shaft hub connections, we have updated many standards to the current releases, to the release 2017. You will find this if you go to, for example, in a cylindrical interference fit, you will find these updated standards in the report as typically done. And you can see this is now the 17. So this is also an, let's say, major job of KISSsoft to provide you with the latest standards. As a last feature, I would like to show you a feature from the language side. As you know, KISSsoft is already quite far in languages. We have from German to the typical Roman to the Russian standard, and as a next one, the Chinese standard is planned. So if we click on that, we can see we are very far with the software actually already. However, we did not publish this language for the 2018 release, but we want to make it available for you on your request. If you want to already use it with your maybe with your sites and facilities in China, you can already ask us to provide you a license for that, and you can try on that, and we also appreciate your feedback on that. Okay, so I go back to English, and here is also from my side the highlights in the KISSsoft 2018. I wanted to show you is currently done. We really decided on the highlights. We think this is the most valuable now for you to show in a short time. Of course, there are very many more which we could not show you at this short time. If you ever want to try on these or on the release itself, just ask us for a test version. We are happy to provide you test versions. Also, we like to give you specific web meetings where we have more time for your questions. So also just ask us for these for web meetings if you would like so. As Mr. Tsikur already mentioned, I just want to remind on that the KISSsoft presentation will be on 21st of June. You will find the subscription on our homepage, and again, also our handouts with special flyers we will provide on our homepage, the same as also the presentation which we recorded at the moment. You will find also then on our homepage. So in this point, we want to thank you again for your attention. We hope we could inform you about our nice features, and we are happy to hear from you again. Thanks a lot, and bye-bye.